Our goal for this demo is to practice creating EC2 instances and to do something with one of those instances that is at least a little non-trivial. And so the example task that I've chosen is to create a GitHub alternative. So if you've written code, particularly in the last couple of years, and you've worked with other people on code, you've almost certainly used Git and GitHub to store that code and the updates to the code, the history of the repository, and to collaborate with other people. GitHub is great, but there are open source alternatives to GitHub. So if you're the kind of person who wants to run his or her own infrastructure, there are alternatives available to you. And in particular, one that we're going to work with is called Gitea. If you go to the website, Gitea.com, and you look at the About page, it's maybe not entirely obvious what Gitea does, a private, fast, reliable DevOps platform. There is a cloud-hosted version, so you can pay a company to manage this for you. But if you're interested in cloud computing, you're probably going to want to learn how to do this yourself. And so if we scroll down a little, we can actually see what Gitea gives us. And it's actually pretty similar in appearance to what you see when you log into GitHub. You can see repositories that you've worked on. You can see updates. You can see a graphical display of your commits, and so on. So what we're going to do is we're going to today set up an EC2 instance running Ubuntu. We're going to create a Gitea service user on that instance, set up directories for the new user, install Gitea, set Gitea up as a service that runs automatically on our instance, choose a database, and then finally, once that's all running, we're going to create a Git repository using our personal Gitea instance, essentially going through all the steps you would need to set up a very, very basic Gitea server. Now, at the very end of this demonstration, I'm going to talk through some of the ways in which this is not complete, but it's worth noting now that what we're doing is just walking through the very, very basics to practice working with EC2 instances and basic Linux system administration. So there are going to be reasons that we would not probably want to use this Gitea server in production without going through some additional steps, which we'll talk about later in the course. So it's good to keep that in mind, but practice makes perfect, and this is where we are going to start practicing. So that's Gitea, and now we're going to switch over to AWS. So when you log into AWS, you should see something like a console home that shows maybe some things you've visited recently, applications. You probably won't have any of these running, along with links to help material. We want to go to EC2. If you've visited EC2 recently, it'll show up here, but you can also click on this square and go down to Compute, and EC2 will be one of the first things that shows up in that list. So remember, as the tooltip shows us, EC2 is Amazon's web service for creating virtual servers in the cloud. So these are computers that you rent. So if I click on EC2, it takes me to a page that provides me all kinds of information about EC2, but we're just going to jump straight in to creating a new EC2 instance. So there are lots of ways to do this, but probably the easiest from this page is to just click the Launch Instance button. And when I do that, it's going to take me to a page that lets me specify the parameters of the server that I want to create. So we're going to walk through this together, and it's mostly pretty straightforward. So what are we going to call this server? We're going to call this server, I'm going to call mine Hello Gitea. When you do this, you can call it whatever you want. There are many, many OS images, as this search bar indicates, but helpfully, one of the most convenient ones to use, and one that we'll use a lot in our class, is the Ubuntu OS image. So this gives us an installation of Ubuntu Server. It's version 2404 LTS with an SSD volume. So the defaults here are pretty good. A 64-bit x86 architecture works great, and so we can keep on going. It's worth probably noting if you have the free tier, as you should if you're in my class, you can see that this is free tier eligible. So that's something to look out for if you're just playing around with this on your own time. If we scroll down, we can see that the instance type here is T3.micro. So if I expand this, there's a large number of different possible instance types that are tuned to all kinds of different compute needs that you may have. For us, we're interested in the free tier eligible instance types. And for our purposes for this demo, and even for probably light single user type use for a Git server, something like T3 micro is going to be just fine. So we're going to keep that default. And then we move on to the key pair. So you may remember I talked about in class this idea of using public key cryptography to log into remote systems. This is the default way that EC2 works. So we need to select a key pair or create a new one. I'm just going to click Create a New Key Pair, and I'm going to get some options. As I mentioned in class, RSA is fine. ED25519 is a slightly newer option that is one that I like to go with these days. It probably ultimately does not matter for your use at this moment, which you choose. You've got to give it a name. So I'm going to call this my Gitea key pair, which I will be able to use in the future. And then the last thing we need to specify before we create the key pair is the file format for our private key file. You have basically two options here that correspond to whether you are working on a Mac or in Linux versus if you are working on Windows. So .pem is the key format that you're going to want to use if you're working with OpenSSH, which is what you're going to be doing if you're on Linux or on a Mac. PPK files are what you're going to use with PuTTY, which is the program that we are going to use as our SSH client when we are working on the computer labs in Pangbourne Hall. So if you're running through this demo in class, in a computer lab on campus, you'll want to select PPK as your option. But for our purposes, in this demo, since I'm running on a Mac, I'm going to go with a .pem file. So I click Create Key Pair. And then I get prompted to download something. This is normal. I'm downloading the private key file. And so I'm going to call that. So the name is pre-filled with whatever name I gave the key pair. I just hit save, and that's going to go to my downloads. You can see that it is a small file, 387 bytes. This contains your private key, so I'm not going to show you that. And when we go back to the instance creation page, you can see that Gitea key pair is the option that is selected. You can see that I've done a couple of different tests here, and so there are several options. If you create multiple key pairs, just make sure you remember which one you're using, and you have the private key file. So now, with that key pair settled, we go to Network Settings. The first time you do this, you may have to set up a virtual private cloud. Amazon will make it very obvious what you have to do, and you can choose sensible defaults for the purposes of the demo. So once you do that, you have to set up a firewall, and in particular, a security group. So this is basically going to create rules that say who can access the server that you are creating. We're going to allow the default option, which is the SSH traffic from anywhere, which is what that string means, is allowed. And the way that EC2 works is that if you don't specify an explicit rule allowing something, it is not allowed. So we're going to start there, and then in just a minute, we're going to go ahead and edit the rules directly to allow just a little bit more traffic to our server. The last step we need to do to create our instance is to configure the storage. 8 gigabytes is probably fine, but I have seen a recommendation that 20 gigabytes is a better option for the particular Gitea setup that we are going with. So a 20 gigabyte GP3 root volume is perfectly acceptable for our uses. We don't need to specify any advanced details. So with these parameters set, you can see over here on the right through the summary that we are going to be setting up an Ubuntu 24.04 T3 microserver. We're creating a new security group with a 20 gigabyte drive, and I can just click Launch Instance. And the instance was successfully created. You can do a couple things here. So you could directly connect to the instance via the browser. We're not going to do that. We're going to switch over to a terminal and get some practice with that. But once you see this page, you can just click on the instance and get an instance summary. And this is going to give you all kinds of information that you're going to want to use to connect to your system. So now that we have our running instance, we can first confirm that it is in fact running. But like I said, we need to update the security rules to enable us to access the server via a web page. So I scroll down a little bit and I click security, and I can see the inbound rules and the outbound rules. So right now, what this means is that I can access the server via port 22, which is SSH from anywhere, and then the server can send things out on all ports to anywhere. So if I click on the link Launch Wizard 4 for the security group, I can see a list of all security groups that I want to create, and I can click on this security group ID to look at the inbound rules for our server. I could also look at the outbound rules, but right now for this demo, I want to be able to access the page from anywhere, the page that we're going to create. So I'm going to edit this inbound rule, though, because right now we can SSH in, but that is not all we want to do, because we want to be able to access Gitea from a browser, just as if we were working with GitHub. So I'm going to keep this first rule as is, and I'm going to add a second rule, which is going to be custom TCP. We're only going to allow one port, which is going to be port 3000. And we're going to select the CIDR block of all zeros, which means that anyone is going to be able to go to access our server through TCP on port 3000. So we save that rule, and then we're good. So at this point, we are just about ready to SSH in to our instance. So to do that, We want to go back to our instances. We can do that here on the left. We can see our list of instances. So you can get the public IP address here. Let's go back to our instance summary page. And what we're going to want is we're going to want the public IPv4 address. And Amazon very helpfully gives you this button to copy the IPv4 address to the clipboard. So at this point, we can switch gears to the terminal. And so I do that, and you can see that I am in my home directory because of the tilde here. I'm going to, just for the purposes of this demo, create a new directory called Gitea demo, and then I'm going to cd into that. And this is where I'm going to keep the private key file that I'm going to use to SSH into my EC2 instance, which is currently running. So I need to copy that file from downloads, and it's called GiteaKeyPair.pem to this location. So this command, when I hit enter, is going to copy the key file into the directory that I am currently in. And so if I type ls, I can see the contents. Now, something that is worth noting is that SSH is very particular about the security of the file that you use when you use a key to log into a remote site. So if I ask for just a little bit more detail from ls, I can see here that as the owner of this file, I can read and write the file, and everyone else is allowed to read the file but neither write nor execute it. That's what those dashes mean. Unfortunately, this is actually too permissive for SSH to use as a file to log into a remote server. So if I try to do that, so if I do ssh-i GiteaKeyPair.pem, and then I try to log in, and is this still saved? It is. And I try to log in as the Ubuntu user at the public IP address of my EC2 instance, I'm going to get an error. And that, well, first it's going to ask me if I want to continue connecting because I have not actually connected to this machine before. So I'm going to type yes, and then I'm going to get an error. And that error is that the permissions 0644 for GiteaKeyPair.pem are too open. It is required that your private key files are not accessible by anyone else. So we get a bad permission and then permission denied public key. The fix for this is pretty simple. I just run the command chmod 400 and then the name of the file. Now, before I do that, remember this line here where my cursor is. So it's rw-r-r-r-, which is an indication of the security or the permissions of the file. So I chmod, and then I do ls-l again. I'm going to clear the screen by holding down Control and hitting L. And now the permissions are much more restrictive. So it's just R and nothing else. And so if I go back to my command history and I look at what I typed, 4 is 100, and then the 2 zeros in this command are the other 6 zeros. So there's a one-to-one mapping between the read, write, execute permissions in these three groups and the binary representation of the number that you pass in here. The upshot of that is that now I am the only person who is allowed to read that file. And so if I rerun this command and SSH into my server, I should be good to go. So let's just confirm that that is the case. And it looks like we are. So I run SSH, I give the key file, I specify the user and the IP address. Now that user is just the default, which showed up as a piece of information in the instance setup when we were launching the instance. And so then we just get a bunch of information about the computer that we have logged into. So we are logged into that EC2 instance. You can see, for example, that we have about 20 gigabytes of disk to play with. And then we get a bunch of information about the instance. So the first thing we're going to do now that we're here, another way you can tell we're here is that my prompt has changed. So the first thing we're going to do is we're going to update the packages that are present here. So I type the command sudo apt update, and this is looking into what packages are available. It's fetching some information. And we see that 69 packages could be upgraded. So then I'm going to run the command sudo apt upgrade -y. That -y means don't ask me repeatedly what to do, just do the thing that you should or that you want to. In this case, should and want to are the same. So we're updating the system. And then we see once that update starts, no VM guests are running outdated hypervisor binaries on this host. Now you know what that is from last lecture. So once we do that, we're going to install a handful of particular packages we need for this demo. So the way that we do that is by running the command sudo apt install -y, and then we list the packages. At this point, I should probably say that sudo is the command that allows us to run code or programs as the administrator on this computer. Apt is the program that handles the management of packages. Install is a subcommand that we are giving to apt. And then -y is an option that is don't ask permission, just do the thing that you would normally ask me to do. And then we list the things that we want. So Git is the version control system. SQLite 3 is a database. Curl is a program for using the terminal to download information or data from other places. And this certificates file or program package is something that we're going to use to help us with the website. So I hit enter, and those packages are installed. At this point, we get the same message: no VM guests running outdated hypervisor. And so the next step is that we want to create a new user. This is pretty standard. So we are going to run the command sudo add user. In the terminal, when you want to write a command on multiple lines, you use a backslash, and that will continue the command. And so we're creating a system user. We're going to specify that that system user should have the shell bin bash. We're going to create a home directory for that user. This is a short string describing that user that's going to be written to some files. And additionally, we are going to create a group called Git, which is also the name of our user. And so when we run that command, we see the command getting executed. So we have a user ID getting selected. That range 100 to 999 is because we're creating a system user. We are adding the system user, adding a new group, adding the new user with group Git, and creating the home directory. And we are all good to go. So at this point, we've created a new user, which is a typical step when you're creating a new system service on a system. You create a user specifically for that service. And now we just need to create a bunch of directories. So we'll do these one at a time. So the makedir command you saw me run on my local MacBook. I didn't have to run that command as sudo because I was the owner of the directory in which I was running makedir. Because I am creating something in a system directory, though, I have to run sudo. And so this command is going to create a set of new directories. And I'm just going to continue. So etc, remember, is the directory that stores configuration information. And once we create those, we have to change their owners. So remember, every file has an owner and a group, and the chown command is going to change the owner and group of varlib Gitea, which is a directory, to Git and Git. So the user Git and the group Git. Similarly, we're going to change the configuration permission to root or owner to root and Git. And then, last but not least, we are going to change the permissions of the Gitea directory. At this point, we're in a position where we can install the Gitea binary. So you could, in principle, I suppose, download the software and figure out how to build it. There is a nice option, though, for just downloading the binary you need directly. And so the way you do that is curl. So in general, on the terminal, curl is a program you can use to download from remote servers. You give a path, and here I'm using a pipe, and I am going to put whatever I download into a binary named Gitea, and I'm also going to not print anything out. So at this point, I should be able to look at user local bin and see. This is probably going to show a bajillion things. No, just one. And it's actually the one thing we want, which is Gitea. So we've successfully downloaded the Gitea server binary into user local bin, which is where we want to put system software. But if we look at, if we just run that command again and ask for additional information by passing in -L, we can see that the execute flag is not marked for anyone. This is a binary, and so binaries should be executable. And so the way that we're going to deal with that is by using a slight variant of the chmod command. So instead of passing in a number, I'm just going to say add the execute flag to this file. And so if I LSL again, you can see that now anyone can execute this file. You can also see as just a nice added benefit of the terminal that now that file is listed as bold and green, indicating that it is executable. So our next step is that we need to write some configuration files, and there are several ways you can do this. I'm going to show you one of my preferred ways, which is using what's called Emacs. So Emacs is a text editor and so much more. And it's going to allow us to edit text in a convenient way on the terminal. So if I do sudo apt install Emacs, which is what I just pasted into the terminal, and hit enter, you can see that unlike the packages that we installed right when we logged into the server, this one has a lot of dependencies. And so we get prompted, do we want to install all of these things? So Emacs is actually a pretty big program or package. It requires nearly 0.5 GB of disk space, which for demo purposes is fine. If you're concerned about disk space, ask me in class what some other alternatives are. So we get asked, do you want to continue? And you'll notice that we have two options shown in the square brackets. We have a Y and an N corresponding to yes and no. That Y is capitalized because that's the default. So whenever you see a default option on the terminal, or whenever you see a capitalized option, that is the default. So if I just hit enter, that is saying yes. Now, Emacs, like I said, is very powerful and can do lots of things. One of those things is it can send mail, and so you're going to get prompted to do a general mail configuration type. I'm just going to say no configuration and keep going because we don't need our text editor to handle email for us. So we can see that the dependencies of Emacs are getting installed, and then Emacs will eventually be installed as well. This is the advantage of a package manager. You don't have to manually know all of these dependencies and install them yourself. apt, the Ubuntu package manager will just handle that for you. So now that that's done, we can use Emacs as a text editor to edit a file. So this is going to be the configuration of Gitea as a system service. So the way that this is going to work is that when this computer boots up, Gitea will automatically be started with the appropriate configuration. You won't have to set that up yourself. Because I am modifying a file under Etsy, I need to sudo Emacs, and we get the Emacs editor. So the configuration I'm going to use is something that is provided as a simple example config. And we don't really need to worry about the details of what is being set. You can see some things that probably are pretty intuitive. So the user of this service is Git, the group is Git. We're going to use the directories that we created. The program that should be run is the one that we just downloaded. We are then going to save this file. The way you do that is you hold down Control, and then you hit X, and you can see at the very bottom of the screen that C-X showed up, and then still holding down Control, you hit S. And you can see wrote Gitea.service. So that means we saved this file at that location. Then to exit Emacs, you still holding down Control, you hit X, and you can see C-X showed up, and then still holding down Control, you hit C. And now we have set up the service configuration. At this point, we just need to turn it on. And we do that in 3 steps. So we're going to run this sudo system control, and that is going to tell Ubuntu as a server what it should be doing. So we enable Gitea, and then once it's enabled, we start it. And if I go back to a browser, I was able to just paste the IP address, and the port number, and you can see that I am confronted with a request to set up a database. So I'm going to do that by just specifying SQLite 3. One of the things you would want to do if this were a more permanent setup for Gitea would be you would want to choose maybe a fancier database like Postgres or MySQL. SQLite 3 is going to be just fine, though, for us. And at this point, I believe that everything else should be good to go. We're not going to worry about email. That's another thing that you would want to set up. So we just click the button, install Gitea, and it is now loading. Which was pretty quick. Excellent. All is well in the world. At this point, we need to create a new user. So because this is your own service, it really doesn't matter what your username is. You're not going to have to share unless you want to. I'm just going to make my username Richard. I'm required to provide a username, an email address. It turns out that this actually does not matter for our purposes now. It would if you wanted to set up something more permanent. So if I do foo at example.com, then I should be fine. And you do want to use a real password because even though this is only just a demo, this is on the live internet. By the time you watch this video, this server will be gone. But if you were watching this and the server happened to be still up, you would be able to log in as well or create a new user account. So I'm going to not use that suggestion. I'm just going to type my own password. I'm not going to tell you what it is. And I'm going to register my account. I'm not going to add that to LastPass. And so at this point, I have a running Gitea server, and I am logged in as Richard, which is pretty amazing. So now the last thing we're going to do is we are going to create a new repository. We're going to download that repository, and we are going to make some changes and then push those changes back to show that this is functional. So I'm going to click the new repository button. We're going to call this just Howdy. I don't need to make it private. You can enter a description if you wanted. All of this stuff mirrors what you would do in GitHub. All you really need is the owner and the name. So I'm going to create this repository. And then just like in GitHub, you get instructions. And so we are going to just follow these instructions to a T. So I'm going to switch back here. I'm going to create a new tab. Now you'll notice when I create a new tab, I'm no longer in my EC2 server. You can see I'm user Richard at Mac. And I am in Gitea demo, which is just fine. So I'm going to create, what do I call this? I call this Howdy. I'm going to create a directory Howdy. I'm going to cd into Howdy. And then I am just going to follow these instructions. So I'm going to touch readme.md. Touch is the command that just creates files without putting anything in them. So now if I ls, this command exists. If I do ls-l, you can see that the file readme.md exists but has 0 bytes, so there's nothing in it. I then am going to do git init, and I am, again, just following instructions here, exactly what it tells me to do. And you can see that, as expected, I have an initialized empty Git repository. I then am going to check out main, and I'm going to add the README. And now if I do git status, you can see I'm on branch main. There have been no commits. I do have a change to be committed, though, which is that there is a new file, readme.md. So I can then commit, and we see 1 file changed, 0 insertions, 0 deletions. At this point, I'm going to add a remote. And you can see I've specified the IP address, the port, and then a path. And the very last thing I do following these instructions is I push my changes back to the server. At this point, it's going to prompt me for the username that I just created. So this is the Gitea user information that you just typed in when you created your account. So remember, my username was Richard, and now I'm going to type that password that I didn't tell you and hope that I do not typo it. I didn't typo it. You can see that I have written some objects and sent all of that to the server. And if I go back and refresh this page, look at that, just as if we were on GitHub. Now, this is not super interesting because howdy is empty, or the README is empty. And so if I instead, let's just do code, I guess, in this directory. Yes, I trust myself. I'm going to create a file called hello.py. This is a Python file, and so I can do something like if name is main, then print hello world. I can then save this, close that. If I type ls, we can see that I have hello.py. I use UV as my Python package manager. It's worth looking into. It does things a little differently. So if you want to run a script, you type UV run hello.py, and unsurprisingly, we get hello world. If I type git status, we can see that I have an untracked file because I just created it. So if I do git add hello.py and I git commit, adding, I'm using the -m to add a message, adding hello.py to repo, and do git status. I am ahead of origin main by 1 commit. Git push origin main, and we can see that that looks successful, but let's confirm. If I refresh my page, you can see that I now have hello.py there. And if I click on that file, you can see that Gitea knows that this is a Python file, that it has 3 lines of code and 53 bytes, and you get some nice syntax highlighting. So now we've created a repository, and we have populated that repository with some code, which is pretty good. And the last thing I'm going to do before I shut this down is I'm going to run a series of commands to make the permissions on my server just a little bit more restrictive. This is moving in the direction of what you would want to do if you were going to run a Gitea server for yourself and just kind of use it on a daily basis. First, I'm going to change the permissions on etc Gitea to be a little more restrictive than they were when I set them. 7 in general means anything you want, and that first number is the user. So the owner of the file can still do whatever. Other people have more restrictions. Similarly, we are going to change the permissions on this file, app.ini, and then we're going to change the owner of that file. And once we've done this, we are going to restart the Gitea service, which looks like it was successful. And sure enough, I can go back to the browser and I can refresh the page. And if the server had died for some reason when I restarted it, this refresh would not work. And you can see there that there's my first block of public activity. At this point, if we were interested in going beyond the basics of this demo, you'd want to do a couple things. So you may notice this not secure block here. That's because we are not using HTTPS. We're just using HTTP. So that is not ideal. You'd want to put this behind HTTPS. You would probably also want to specify an actual URL with a proper name rather than typing the IP address directly. So you'd have to play around with DNS settings and a domain name. You'd want to enable backups. So you'd want to back up the SQLite database that powers this website. You'd want to back up your repositories. You want to back up your configuration. We'll talk about backups later on in the semester. You'd want to make a choice about what kind of Git authentication method you'll use. So you may have noticed that we went with the default for Git, which is typing a username and a password, which is fine and good. But if you've used GitHub recently, you know that SSH is the more standard approach, and you can set that up. It requires configuring ports on your server a little differently than what we did, but it's not too bad. And then you'd probably want to configure email properly so that the system would send emails to do things like provide updates, or if you forgot your password or any other number of other things. And then lastly, there are some other things you would want to do to probably lock down your EC2 instance. So you'd want to restrict ports. You'd want to force the system to only use HTTPS. And unless you were running this as some kind of public service for other people, you'd probably want to disable registration so that new users can't be created for your Gitea server. And so with that, we are done with the demo. There's one last thing I want to show you to do, which is very, very important. And that is you want to learn how to terminate instances. Now, we're on the free tier at this moment, which means that we're not getting charged for this. But in real life, even a T3 micro instance costs, I want to say it's a penny an hour or something like that. And if you work out the math, running a T3 micro instance for all of the hours in a month, which is a little over 700-ish, will end up costing you, it's less than $10, but it's more than $5. So, that's a coffee at Starbucks. And so you want to be responsible about managing your instance. And when you're done using it, you want to stop the instance, or in this case, I'm going to terminate this instance completely. And it's going to ask me, do you want to do this? You're going to lose stuff. Be careful. You can also skip the OS shutdown, which is going to just expedite the termination. Now, if you were on a system where you really cared about data, you wouldn't want to do this. You would want to shut down gracefully and properly. We're not interested in being graceful at this moment. And so we get a warning. This can result in data corruption and system instability, but this instance is going away. It's going to die and never come back. And so I'm going to click the terminate delete instance, and we've initiated termination. So we can see that the instance is shutting down. And if I go back to the list of instances, you can see that the instance is shutting down. I can refresh this, and it's still shutting down. And eventually, this will move from a shutting down state to a has shut down state. But we don't need to wait for that. So if you look at the demo slides that have been posted to the course webpage, I have at the very tail end of those slides listed the programs that we use at the terminal to do everything that we did in this demo. So everything from chmod to curl to T, and then I listed a couple that we didn't, or at least one that we didn't actually end up using because everything went well. But if you have to debug there, it's terminated. If you have to debug, there are programs you can use to get the output of a system service. So those are in the slides. For the purposes of our course, you're going to be reproducing this at our next meeting in a week. And so watch this. Watch it again if you feel like you need to. And feel free to ask questions by email and compare against the slides.